Let's talk about designing a database server infrastructure. We're going to look at planning our hardware, what our considerations for server consolidation might be. Why server consolidation? What are we talking about there? We're talking about putting several servers together either in a management group or in some sort of organization that we can find a single point or just a few points where we can read the health of those servers and so on. We're going to talk more about that. And then managing server resources in a consolidated database infrastructure. Okay. First off, let's look at SQL design. When we set up to make a new database or a new instance, we have to do several things. One, identify the key stakeholders and business requirements. What are we talking about? Why is that important? Because it would be very foolish for us to assume that we can design one database and all aspects of our business can use that database. That would be silly. Where I used to be a data architect at ASI, we had a content management system template and then would build out to the specific requirements of the users and the business rules. What are they trying to do with it? In our organization, we had databases that were both internal for Indianapolis, in London, and Cebu in the Philippines, and so on. And we had applications that were designed for our retail apps. Primarily, our retail apps were hosted in Salesforce, which is a cloud application, keeps its data there. But being good paranoid data people that I am, we made sure that our data was replicated locally in each store. So the design of that database had to meet the business requirements of the application that was actually selling products. It was actually running, we had 13 different product sales apps around the world, and those databases had to match the requirements for each one of those countries, each one of those regions, and so on. To assess the existing environment, sometimes you will find that when you look at what you've got built already, what you have existing in the server design will serve what you're trying to do. So a minimum of repeat work should be your goal. If I have a database, just like I told you earlier, we had a content management system was our base format for any of our new brands or lines that were going to retail. We saved ourselves a lot of work and ensured that we had a lot of interoperability, intercompatibility, because a lot of the basic things were still the same in each database. Pretty handy. So assess your current environment to figure out what you can reuse, what you can do that you've already done. Identify the right addition. Licenses are a major investment, aren't they? We have to be responsible to our companies that we're working with for licensing. We want to make it as streamlined and as inexpensive as possible. There are many places that I've been to as a consultant that they're using like SQL Enterprise for something that's a local internal app. Why did you need a new instance of SQL Enterprise? You could have done the same thing with SQL Standard. In some cases, they could have done the same thing with SQL Web. Save them licensing money, and save the company more headaches in maintenance and so on. Plan the database infrastructure and assess the hardware requirements. Okay. Here's some fundamental rules about hardware requirements that you need to know. One, if you have only 2 drives in a machine, and that's the machine for the enterprise, you need to keep your data on one and use the other for everything else. This is an important rule to remember for a test. If you're given 2 drives and asked how you should organize it, or 2 servers and ask how you organize it, One should have all the data. The other should run everything else. When we deal with a professional data environment, when we deal with a more sophisticated data environment, we want to be sure that we have set up redundancy, right? We want to have a RAID for hardware tolerance. A RAID is a redundant array of inexpensive or now independent disks. What this does is this allows us to lose one disk and be able to rebuild it once we replace that physical disk. We can rebuild one missing disk. Now, if you ever lose two at the same time, you're kind of out of luck, because we can't find for two variables. We can only find for one. And the idea, if you think of 3 disks in an array, 3 disks in a RAID, what you would have is, let's say the word data is striped across all 3. I know that the word is supposed to be data. There's a D and an A on disk 1, there's a T on disk 2, and there's an A on disk 3. Okay? If I lose either one of those disks, I know the word is supposed to be data, right? So I can spell it from losing just one disk. Okay? I can't, you have to remember that SQL does things in a mathematical organization. I can't find for 2 variables to resolve to the same question. So for example, my data, if I lost the center disk, I have a DA and an A. Mathematically, SQL can deduce, or your network operating system, when it's set up properly in a RAID, can deduce that there needs to be a T on that middle drive. Okay? That's a RAID. That's what we talk about as one part of making sure that we have high availability. Fault tolerance for the hardware, fault tolerance for the software. Okay? We can do the software fault tolerance with a high availability group, which can be basically combining several techniques for a failover cluster. Our goal, and we'll talk in more depth with that a little bit later on, but our goal with high availability is to reach what's called the 5 nines. Now, if you're not familiar with the 5 nines, that's okay. People don't walk around the street saying 5 nines all the time. What that stands for is we want our data to be available. Now remember the key word, available, 99.999% of the time, which basically means your data can be unavailable less than 5 minutes a year. And you say, Mike, how is that possible? We got to do patching, we got to do other stuff. Well, that's why we have redundant servers and redundant copies of the data. We have actually a situation where I can take one server down, patch it, fix it, get it updated, bring it up, then bring the other one down. And all that time, even though I might be serving fewer requests, even though I might have scaled down a little bit for a short period of time, I still have my data available. That still counts as going toward the 5 nines. Okay? You got to plan your database infrastructure. You got to plan for consolidation. It makes sense to be able to look at several instances, several databases from one instance or from one database. This is part of the advantage of consolidating, enlisting master servers and slaves, basically, to run jobs on and see the reports all on the one server. Also setting up database groups so that we can consolidate their work as well. It's important. And then we design our schema. When I used to do a lot of consulting on previous versions of SQL, I had a white round table, basically, that was made of the masonite. And on that white table, I would use dry erase markers or wet erase markers sometimes, depending on what mood I was in. Usually the wet erase, because it was really easy to get rid of them. And draw out. So I could see in one fell swoop that whole database diagram. I could lay it all out. I could draw it out, and I used Post-it notes for relationships, and I did a lot of other things, and I got a lot of amusement from my wife and sons on that. They thought that was pretty funny, but it was a pretty effective tool for me back in the day, so to speak. Now we can do that same thing with Visio, ORM, object relational modeling tools, and so on. Plan the placement of the database files. Now, again, we're going to talk about all these things individually, but what do you think I need to worry about with the database files? I'm looking at, I want plenty of room to expand if I need it. I'm looking at, I want to be able to have various IOs available to me, in other words, other disk structures available to me, so that I can create file groups for large objects, that I can get the processing of them off the primary group where that disk structure is running the main part of SQL, and move a lot of that processing off to other disk groups. Okay? That's important. Storage of unstructured data. How much room am I going to allow for the managed heap? In my growth, I need to be concerned with the areas that are taken by my data types and how much room am I going to allow for growth, keeping in mind that my managed heap is not organized the same way a clustered index is organized. It is pointers, index allocation mapping documents that point to various data pages contained in the heap where my data may reside. When you work with SQL, you cannot put more than 80-60 bytes in a single row. It's a mathematical limit. Why? Because that's how much room we have on a data page, an 8 kilobyte page. We have 80-60 bytes. The rest of it's overhead for SQL. So a row cannot extend that. Well, you say, Mike, what are you talking about? I got images in there that are 256 gig, meg, whatever. What happens in those cases is in the row, there's a pointer. And there's a pointer to that blob, that binary large object out on the heap, which is organized by mapping documents and groups of tables that are more freely structured. When you write data to your B tree, your normal node and leaf level, you write data to pages that split. When you write data to the heap, the next available takes the data. Whatever page has got room takes it. The organization's very different. So I have to keep in mind what kind of growth I'm expecting when I place my files. Also, I would prefer to place my log files on a separate disk from my data files. It's not a bad idea. Why? Because my log files are the LDF files, okay? And those are log definition files. My file groups are NDF. We'll talk about those later. I kind of mentioned them already. And then my main data files are MDF. What I want to do with my LDF files is separate them a little bit from the MDF on a different drive or drive structure, because what that does is that allows those to be recovered, or the data to be recovered, or both. Give me a separation where I'm not looking at a single point of failure in my database. That's what I'm looking for. Okay. Storage of unstructured data is what I was talking about when I was talking about the heap. Design your indexes for performance. Now, one thing about 2012, every table wants, needs, loves a clustered index. You have to use one on every table to make your other index structure effective. You must have one to set up full text indexing. Your non-clustered indexes beg for hints from the clustered index. So it's much more efficient to make sure that you have a clustered index on each table. There can only be one on a table, but that's all you need, okay? So if I'm going to design my indexes for performance, I want to make sure that there is a clustered index on each table, and I want to make sure that my non-clustered indexes are created in a manner to either cover a query or manage the heap or do something with a purpose. And then, of course, database and server security is vital. You must plan for security. So many things go into that subject.